Okay, let's now perhaps look at this state diagram, and from this state diagram let's see if we can actually just come up with a state table. And once we've got the state table, it's relatively straightforward and easy to get the logic, and then I think we'll conclude this session really with a block diagram, as it were, of the overall system. Alright, state diagram then. Alright, now what we need to do is label these states, okay? We have 1, 2, 3, 4, 5, 6 states. So we're going to need 3 state variables. Okay, so look, let's do this. This would be A, B, C. This is the 0, 0, 0 state. This would be the 0, 0, 1 state. This could be the 0, 1, 0 state, the 0, 1, 1 state, the 1, 0, 0 state, and then of course this would be the 1, 0, 1 state. So there we are. We've labeled our states. All right. Now what we'll do then is we'll look at a state table here, and then we'll refer back to this as we go. Alright, here's the development of the state table. Okay, now what I'm showing on this side are inputs. We have the SW input coming from the SR latch. We have the carry out coming from the counter. We have A, B, C, which of course are the outputs from the state variable flip-flops that indicate the present state, the current state that we're in. Then these are all outputs. We have special outputs, the next state outputs, that's AN, BN, CN. And then of course we have our lights over here, and then we have the reset that goes to the SR latch, and then we have the clear, which is an output that goes to the counter. All right, so let's start this process, okay? Supposing I'm in the 0, 0, 0 state. All right, am I concerned about the switch? Am I concerned about the carry out? So let's have a quick look at the state diagram. Okay, here we are. If I'm in the 0, 0, 0 state, okay, I'm really just concerned with this one input here, SW. If SW is 0, I stay in this 0, 0, 0 state. On the other hand, if SW were a 1, when I get the next leading edge of the clock, I would move to the 0, 0, 1 state. All right, so we'll try to then reflect those two conditions in that state. If SW is 0, we stay in the same state. SW 1, on the next clock, we would move to the 0, 0, 1 state. Okay, so we don't care about the carry out. I'll represent that with a little x. If the switch were a 0, though, coming from the SR latch, then when I get the clock edge, I'm not going to change states. I'll stay in the same state. Okay. What lights do I want on? Well, it's whatever is in this rectangular box. Well, look, we want the green light on. We want, and I'm assuming these are high acting signals. All of these are high acting apart from LCLR, which is low acting. So all of these high acting, this is a low acting signal. Yellow light off. Red light off. I want to keep the people waiting. Go light is what? Off, of course. Am I resetting at this point? Absolutely not. Am I clearing at this point? Since it's a low acting signal, I'm not clearing. I make that a 1 because it's a low acting signal. Okay. If I'm in the same state, the 0, 0, 0 state, I don't care about the carry out, but if the switch were a 1, as we saw before, I would move what? On the next clock edge, I'd move to the 0, 0, 1 state. Okay. What lights do I want on and conditions here? Well, exactly the same as what we have above. We're not, and remember that's that common mistake, we're not in this state, we're in this state. This is where we are, not here. That's where we go next. We're right here. So it's the same as above. The green light's on and the wait light is on. We're not resetting and we're not clearing. So that's everything in that particular state. If I'm in the 0, 0, 1 state, okay, what happens there? Let's have a look at the state diagram. Okay, if I'm in the 0, 0, 1 state, when the clock comes, I will move to the 0, 1, 0 state. Okay, that's where I go next. But if I'm in the 0, 0, 1 state, these are the conditions, these are the outputs that I want. I want the yellow light on, I want the white light on, and I want to initiate a reset. So those are the things I want to do while I'm in that state. Okay? Okay, so I don't care about the switch anymore. I don't care about the carry out if I'm in the 001 state. The next state I'll go to when I get the leading edge of the clock will be the 010 state. I'm not there now though, that's where I go next. So the lights I want on, or the output conditions that I need, are the output conditions associated with being in the 001 state. So what do I want here? Well, I want the yellow light on, I don't want the red, I want the white light on, I don't want the go. Am I resetting? Yes, we were resetting in that state. Are we clearing in that state? No, we're not clearing in that state. Okay, so that's everything to do with that state. If I'm now in the 010 state, what's going to happen now? Once again, let's have a quick look at the state diagram. Okay, if I'm in the 010 state, okay, what do I want? I want the red light on, I want the white light on, and I want to actually clear the counter in that state. So those are the outputs I want to assert, okay, if I'm in the 010 state. The next state I will go to when I get the leading edge of the system clock will be the 011 state. Okay, so we'll reflect that on our state table. Okay, so I'm in the 010 state, okay. Do I care about the switch? Nope. Do I care about the carry out? Nope. Okay, so what do I want to do here? The next state I would go to on the leading edge of the system clock is the 011 state, but I'm not there now. I'm here now. And so the lights I want on and the output conditions I want are reflected by being in that state there. And so what do I want? It's the 010 state. Basically, I want the red light on, okay? I want the white light on, for sure, yes. Not the go. Am I resetting in that state? No, we decided not to reset in that state. Could if we wanted to. Am I clearing in that state? Absolutely. That's the important bit. We are clearing in that state. And so that's everything really to do with that state. Okay, if I'm in the 011 state, now let's have a look at what's going on. Here I am in the 011 state. Okay, I need to generate north-south red and go. All right, that's what I need to generate. And basically, I am looking at the carry-out. If the carry-out is a 0, I stay in the same state. Otherwise, if the carry-out is a 1 on the next system clock edge, I will move to the 100 state. Okay, just be sure that you're clear on that. If I'm in the 011 state, I need to generate the red and the go. I'm looking at the carry-out. If the carry-out is 0, I stay in that state. If the carry-out is a 1 on the next system clock edge, I will move to the 100 state. So here I'm in the 011 state. Don't care about the switch. Do care about the carry-out. If the carry-out is 0, stay in the same state. Okay. Now in the 011 state, basically what I've got here is the red light on. Okay. I'm letting the people cross the road. Okay, I am not resetting and I'm not clearing. Remember, that's a low active clear. If I'm in the 011 state, don't care about the switch. If the carryout's 1, then on the next system clock, I would move to the 100 state. The conditions here, okay, I'm in the 011 state. So here it's the same as above, 001, 01, 01. Okay, that's that state taken care of. If I'm in the 100 state, let's have a look at that. In the 100 state, I've got the red and the white, and I'm clearing the counter again. On the next clock edge, I'd move to the 101 state. Don't care about the switch, don't care about the carry out if I'm in that state. Okay, 100 state, I don't care about the switch, don't care about the carry out. On the next clock edge, I'd move to the 101 state. So what lights do I have on in this particular state? That's the 100 state. Well, I have basically what? I have the red light on sitting here. I have the white light on. I do not have the go on. I am not initiating a reset, although you could in that state. And then, of course, I am clearing in that state to set me up for the timeout in the next state. Okay, if I'm in the 101 state, let's have a quick look at what's going on there. In the 101 state, I've got north, south, green, and wait, and I'm looking at the carry out. If the carry out 0, stay in that state. When the carry out becomes 1, on the next system clock edge, I go back to the beginning again. Okay, 101 state, I don't care about the switch, but I am looking at the carry out. If the carry out is 0, I stay in the 1, 0, 1 state. Conditions here, of course, would be what? Basically, I've got the green light on. I've got the wait condition on, obviously not the go condition. Am I resetting? I could reset in that state. If I wanted to, that would mean having a 1 there, but I'm certainly not clearing in that state, and I've raised that to a 1. Okay, if I'm in the 1, 0, 1 state, and the carry out were a 1, don't care about the switch, the next state I would go to would be the 0, 0, 0 state, when you get the system clock edge. These conditions, of course, are the same. I'm in the 1, 0, 1 state, so exactly the same conditions here, 1, 0, 0, 1, 0, 0, 1. Okay? Now, is that complete? Yes, it is effectively complete. The only thing I now want you to do is think about the unused states. As we've said before with the unused states, you might want to put these in your state table here so that if you do by some incident here get into an unused state, a glitch in the power or whatever, you actually can then know what your conditions will be here, and you won't have a situation where you have a green light and a go condition. Also, what I want you to do here is design the logic for this. Now remember, how do you do that? Take a column, go down the column, okay, where you have the first product term, read it off. This would be what? CO, A bar, B, C. Next product term, so this would be OR, A, B bar, C bar. Next product term, OR, CO bar, A, B bar, C. Okay, and then continue down for each one of these outputs, and that's how you will figure out the logic. You get the Boolean equations, minimize the Boolean equations, and then you can come up with the logic. And I strongly recommend that you do this for this particular problem. Here is a block diagram of the complete system here. Here's that logic which you have to actually get the Boolean equations, minimize, and develop. Here are your light conditions over here. Here's the next state. Here's the present state. Here's the switch, the SR latch, our switch configuration over here. Here is the counter. Now remember that carry out, of course, is an input to the state machine like so. And remember the clear is coming out of the state machine, really controlling that counter. These are the Q outputs of the counter. We're not using those Q outputs. We're just using the carry out. And of course the reset over here, this reset being generated by your state machine is going where? It's going to the SR latch over here, okay? And just finally, remember this is a clock input on this counter. It's the same clock, all the clocks tied together for each one of these state variable flip-flops, and it's the same clock that actually provides the clock input to the counter as well. Okay, so that's a block diagram of the complete system. I want you to think about this, look at how the state machine is really controlling this counter over here in terms of clearing it. Look at how the counter is providing an input to the state machine. Once again, look at your SR latch here providing an input and the state machine doing the reset function there. Okay, think about that, design the logic that goes in the middle there too. Okay, this will end this particular video.